Hi students, so welcome back. This section is 14.5. Well, this video is about section 14.5, radical equations. That's different from what we've been doing in that now we're gonna be using equations. Okay, we will be using equations. Therefore, there are a couple of rules that we need to learn there. The first one is what to do about well, whenever you get a whenever you get an equation like this with a radical sign in it, right? With a radical in it, and you need to solve. Well, the best and well, the best method to use is to isolate it on one side and then square both sides, because that would be the inverse operation basically, and therefore it would cancel out the radical sign. As a power, a power 2 would cancel out a radical. A radical with an index of 2. All right, so let me see if I can explain it further by let me go ahead and expand this screen here. There you go. And let me go ahead and just write it on this piece of paper here, the equation, and I will teach you the rules as we go. The main rule is to, since now we're working with radical signs, right? Radicals, we are supposed to isolate. And we're solving for x, therefore we have equations. We need to isolate the radical on either side of the equation. It doesn't make a difference, by using the addition or multiplication principle, or both of them together. In this case, we use the addition principle for both sides. This adds up to 0, so I'm just gonna rewrite 2x over here equals 7 plus 4 is 11. And from here, see, now I have isolated my and I'm just gonna put it up here, my radical. So now I can square both sides. You're probably familiar with this step here, like back from when you use the Pythagorean theorem, and this will look similar. But this is exactly the same rule we're using. Okay, right at the end, when you need to square, and see, this would cancel out. Both of these operations would cancel each other out. Therefore, what I have to do is rewrite 2x on this side equals 11 square is 11 times 11 is 121. And then x, if I did everything correctly, well, here divide by 2, it's the multiplication principle, and then I'd end up with 121 over 2. That's strange. Yeah, that should be the answer. 121 over 2. Well, in this case, since I'm solving for x, and therefore I have an equation. Remember that for radicals, we said that we could have 2 different answers. In the first few sections, remember that I told you to think about it as the x as having positive values. Well, it was because we were only using one term expressions. and in this case we're going to be using equations now, and we need to solve for x. Therefore, whenever we get a value for x, we have to go back into the equation, plug it in there, and see if that is gonna make the equation true. Because if it does, then this would be the solution for this equation. Okay, so that's what I'm going to ahead and do now. Okay, because sometimes in this case we only got one solution, but sometimes we get two solutions, and you'll see we'll go over that. I don't have a problem with that. We just need to do it in different problem, different example. So I'm just rewriting here 2 times x, except for now I need to substitute it for this x here, the value for this x, over 2, and then I'm just rewriting everything else. Okay, so let's see. Well, I can see here that since I'm multiplying here, I can remove a factor of 1 here, these two right here, rewrite 121, and I'm just rewriting everything else. Now I can see that the square root of 121 is 11, because I multiplied 11 here times 11, which gave me this 121. So I will rewrite 11 there. Well, write 11 instead of square root of 121, and rewrite everything else. Here I subtract. This gave me back my 7. Oh, 7 equals 7. 7 equals 7. Therefore, this is true. So this value, this constant, gave me a true statement. True statement when I plugged it back into the original equation. Okay. And therefore, this is a solution. This 121 over 2 is a solution of this equation. All right, that's how you and that's an extra step that you need to perform whenever you have variables that are inside a radical sign. Okay, variables inside a radical sign, because you could have variables outside radicals, but then you will need to perform this extra step. Okay, this only applies when you have variables inside the radicals, as radicands. So in this case we did, see, and since sometimes well, we actually do get two different answers, a positive and negative answer, remember, for square roots. We haven't been using that principle up to this point because we have been solving for x and we didn't have an equation. We only worked with single expressions. Okay, so let's go ahead and move on to the next step here. Well, the next example, actually. Let me just fold my paper here, and I will rewrite this expression in my paper. And this section shouldn't be too long, I don't think. Well, oops, that's plus 2 equals square root of, oops, x plus 10. So I might be able to work out a few more problems, and yeah, that's it. So I'm just gonna take it up here because I'm running out of space at the bottom there. All right, let me see. Okay, so what did we say the rule was when we had variables inside radicals? Go ahead and isolate the radical. In this case we have 2, However, one of them is already isolated, so we can go ahead and square both sides. Okay. All right. If I'm squaring this side, this power 2 applies to both factors. See, this is one factor, this 2 is another factor. Okay. So it's just like that rule where you had 2x squared. This 2 would affect those two factors too, just in case you didn't know. Okay, just in case you didn't remember. Here we are not multiplying x plus 2 times x plus 2. No, that's not what we're doing, because we have two factors here, this factor here and this factor here. Okay, we do not have an addition. Okay, I mean there is an addition here, but it's inside the radical sign. Okay, and that would raise this 2 to a power 2. This power 2 will cancel this square root. That will leave that as, and since again we said that these two were factors, so therefore this must be a multiplication. So multiplication between these two terms. Okay, so x plus 2. Now we still write it as inside parentheses because we're still grouping it. So because this radical sign grouped x plus 2, therefore we still need to group it here, except for the radical sign went away. Okay, I will work on this side. This side, the radical sign cancels out because of that power 2. So I'm just rewriting the radicand. Here we just follow the order of operations. 2 squared, that's 4. 4 times x, yeah, we need to distribute that 4 times x and 4 times 2. So that's 4x plus 8. 4 times 2 is 8. Rewrite the right side, and then just continue using the rules for math. Here we need to combine like terms. I can see that x to the power 1 are like terms, yes. So I need to combine it by using the addition principle. So I subtract both sides, x from both sides. I end up with 3x here. Rewrite that 8 plus 8. This adds up to 0. 0 plus 10 is 10. Alright, continue working. I use the addition principle here. Subtract 8 from both sides. This adds up to 0. Rewrite your 3x, because 3x plus 0 is 3x. 10 minus 8 is 2. Positive 2. Alright, so x would be, I'm using the multiplication principle here. 2 over 3. 2 over 3. We need to plug, again, since this x was inside the radical sign, we need to plug in this value that we got into the equation. Okay, into the original equation. So the equation was 2 times square root of x, and now my x is 2 over 3, and plus 2 equals square root, and I'm just rewriting everything and substituting for x. 2 over 3 plus 10. Yep, plus 10. And that's it. I'll just go ahead and proceed, as you would like a math problem. 2 over 3 plus 2. So in this case I can't well, I don't know how to get the square root of 2/3 plus 2, but let's see if by combining them together I can go ahead and do that. So in this case I have an addition. I can think of this as being 2 over 1, and since I'm gonna rewrite this 2 over here, and since I know that I need common denominators, addition is the operation is going to be addition there. And the common denominators, I know that my common denominator is going to be 3. Here for this fraction I did not raise it at all, so I'll rewrite that 2. Here this denominator I raised it by a factor of 3, therefore I need to raise that 2 by a factor of 3. That times 2 is 6 equals, and I keep going. Square root of, again I know that I need 2 fractions with common denominators. Since I raised this denominator by a factor of 3, I need to raise this numerator by a factor of 3 also. And now I have addition of fractions with common denominators. Alright, let me move it up here. There you go. And then just go ahead and add them up. That's 6 plus 2 is 8 over 3 equals square root of 32 over 3. Alright, so hopefully I'm doing everything correctly. Alright. And okay, so all I have to do now is simplify right here. So again, you can think of this as 2 separate radicals, one at the bottom, one at the top, or you can just simplify here inside. I'm rewriting that 2. I'm going to leave them inside. I'm going to simplify here because I know that the factors of 4 is 2 times 2 times 2. I mean the factors of 8 are 2 times 2 times 2 over 3. And the factors of 32, that's 2 times 2. Well, let me ahead and work it out. It turns out as 16. That's 2. That's 8. Just want to make a mistake. And again, you can use calculator. That's fine. I'm doing this by hand. So that's 2. That's 2. Okay, so I was close. It was 1, 2, 3, 4, 5. 2, 3, 4, 5. Yep. So I lost track right about there. Oh, that's 3. All right. So in this case, I can group factors of 2. I'm gonna end up with a leftover there. Here I can group them, those 2. I know those are perfect squares, so I can pull them outside. As multiplication, square root of 2 squared is 2. Rewrite whatever was left inside, which was 2 over 3. Here same thing happens. Square root of 2 squared is 2. Square root of 2 squared is 2. Pull them out as multiplication. Leave the remainder inside, which is 2 over 3. Okay, so now that becomes 4 times square root of 3 equals 4 times the square root of 3. I mean 2 over the square root of 2 over 3. Yeah, no, I didn't worry about that because I knew that the answer is going to be the same. So, and that makes the equation true. So, so this value is a solution of this equation. Okay, so it did work. All right, so that's how you can check if the answer is correct, if the value you got was correct. Hopefully we're gonna get problem with where we get 2 solutions, and I think this is gonna be it, because I've been telling you that to check the answer, and by plugging into the equation, because that's one of the steps, one of the crucial steps, and I haven't been showing you why, but that's because we only got like one answer for those 2 problems. But now it looks like we're gonna get 2 answers. So I'll show you exactly what I mean now. With this problem here, I'm just rewriting everything here, x plus 7. And that way I can move it up because I ran out of room down here. So I'm just moving it up, that's all. X minus 5 equals square root of x. Okay, so the radical is isolated to one side already. I don't need to do anything else. So now I raise both sides by a power of 2. Okay. Here, this does not mean x squared minus 25. Okay, because you have 2 terms here. Okay. This is a perfect square, therefore you need to FOIL. Well, yeah, just gonna do that here. 1 minus 5, x minus 5 times x minus 5. That's what this means. Okay. Yeah, be careful with that. You have 2 terms there, not just one, like we did last time. Equals, well, in this case, those 2 cancel out. Yeah, they cancel each other out, the square root and the power 2. Plus 7. So I'm just rewriting the radicand. Here we actually go ahead and multiply, okay, because we need to combine these 2 together. X squared, FOIL it or multiply, just distribute, multiply the first term times whatever is inside the other term, then multiply the other term times whatever is inside the other parentheses. Yeah, I meant to say parentheses. X times x is x squared minus x times negative 5. It's 5x. Negative 5 times x is 5x, and negative 5 times negative 5 is positive 25. Okay, I'm rewriting the right side here, and now I combine like terms over here first. Negative and a negative, that's and since I'm subtracting, I need to add them up. So that's x squared, because x squared doesn't have a like term over here, and that's negative 10 x plus 25, and I'm rewriting the right side. From here I need to combine like terms. I can see that these x's are like terms, these constants, they of course are like terms, and I do that by using the addition principle. Subtract x from both sides, and I'm gonna go ahead and subtract 7 from both sides. In that way I have everything on one side, okay, because I wanna leave the other side as equals 0. Okay, So in this case I'm subtracting and I have a negative 10 over here. The answer should be negative 11 x, and here I'm subtracting also, so let's subtract there. 25 minus 7 is positive 18. Alright, so now I'm here. If I did everything correctly, we said that we wanted to have x equals 0. I mean the expression equals 0, or the equation equals 0 actually, because we need to factor the whole expression on this side. Okay, and that's going to help. Okay, so if I did everything correctly here, I will end up with the right answer. In this case, I cannot see how to use any of the methods we use, so I'm just going to ahead and do it by trial and error. So for the first variables, the square root of the first term is that term. For the signs, since I have a positive for the second one, I need two signs that will give me positive or multiply together. So either a negative or a positive, negative and a negative, or a positive and a positive. This sign tells me which, a negative and negative. Okay, and then I need two factors that multiply out to 18 and add up to 11. And so I can see that, let me see, 9 times 2, yeah, 9 times 2. 9 times 2, well, negative 9 times a negative 2 give me a positive 18. If I add them up, they give me a negative 11. Okay, so I'm good there. And again, do not miss this right here, because that's important at this step. Because remember that now I have two factors, and the only thing that's going to make this true, this equation true, is if I have a 0 here for any of these two factors. Since I'm multiplying, I will get a 0. Okay, and since I don't know which one of these is a 0, I'm gonna go ahead and set them both equal 0. Okay, so that's a comma right there, and then x minus 2 equals 0, and set them equals 0. Use the addition principle. Okay, use the addition principle. X, this adds up to 0. X equals positive 9. Oops. Use the addition principle again here. At both sides, and this adds up to 0. Rewrite x equals positive 2. See, now we have two different answers. See, now we have a problem, because we don't know which one, if both of these values make the equation true. Okay, that's why we need to plug them into this equation. Okay, and remember that so far we haven't been doing that, but that's because we haven't been working with radicals. Okay, and so we need to check that the first value is 9. Okay, so I'm just going to rewrite it up here, and this is the equation right there to the right. So I'm just working to the right here and substituting, and that's x, that's that would be 9. I should not have done that, because the equation is x minus 5 equals square root of 9, because in this case we plug in the same value for x and add 7 there. Okay, so I'm outside the screen here. I said that since these x's are the same, we need to plug in the same value for this step. Okay, for x for this step. Yes, 9 minus 5 is 4 equals square root of 9 plus 7 is 16. The square root of 16 is 4. Okay. Yeah, because 16 is a perfect square, 4 square, and this equation is true. So 9 does make this equation true. Therefore, it is a solution of this equation. So 9 checks. That's what I would do. I would check it. That's one of the answers. What about for when x equals 2? Okay, so I'm just gonna rewrite everything except for I plug in the value of 2 wherever I see my x in my original equation, and that's square root on this side times over square root of 2 plus 7. Alright, so now I'm here, and 2 minus 5 is negative 3 equals the square root of 9. 7 plus 2 is 9, and 9 is a perfect square. Therefore, the square root of 9 is 3. On this side, I have a negative 3. This equation is false. Therefore, this 2 does not make this equation true. Therefore, it is not a solution of this equation. Okay. Yeah, and that is the right answer. Okay, see, it's right there. All right, and that's how you work, and that's why you have to include that extra step at the end, because sometimes you have two different answers when working with radicals. Okay, and one of them may make the equation true, the other one may not, and sometimes both of them do, but sometimes they don't. Okay, so let's work this one out. No, let me see. No, because we already did using the principle of squaring more than once. Yeah, you can work that one out on your own. If we need to work it out at school, we can do that, but I think that everything you need to know about working out these kinds of equations, you already know. See, isolate the radical, square it, and then just combine like terms. Okay, make one side equal 0. Okay, combine all of your terms on the other side. Yeah, we need that because we need to be able to factor at this point here, to be able to factor and then get a 2 factors. And since the zero product rules tells us that we need to multiply, if we multiply something times 0, that's gonna get us the answer of 0, an answer of 0. Therefore, either of these factors is 0, and then just solve for x separately. Okay, so you can use a comma or an or here to separate both equations. That's okay. Either one will work. The book uses or, I use a comma. And then at this point, go ahead and plug in these 2 values into the equation separately and solve for x. Go ahead and work it out, and if you get a true statement, then the solution is, the value you got is a solution of the equation. If it is false, then it isn't. Okay, All right, so let me go ahead and work out one of these before I end this section. Yeah, because objective A, I mean C, is just applications, and since they give you the formula, there's nothing new, that you can get out of that. So I'm not gonna assign one of those anyway. So I'm just gonna go ahead and work this one out, and that should be the end of this lesson. Okay. So I'm on objective B, using principle of squaring more than once. As long as you can remember that you're supposed to isolate the radical on one side, then square both sides, you should be okay. You don't have to remember the objective B. Watch. X, square root of x minus 1 equals square root of x minus 5. I'm just gonna move up here because I ran out of room down there. And one of the radicals is on one side of the equal sign already, so I'm just gonna go ahead and square both sides. Okay, now this is gonna take a lot of work, well, a little bit more work, but you still should follow the order operations, follow the rules for multiplying radicals, factoring and everything. You already know all that. Okay, so don't panic. All right, so in this case, since we have two terms and we're subtracting, this does not apply to this by itself, to this term, or to this term by itself, and to this term by itself. No, this is a foiling, if that's what you want to call it, foiling multiplication. The square root of x minus 1 times the square root of x minus 1. Yeah, I know I have to repeat myself there but that's because I've seen you guys make this mistake again and again. Okay, and then for the other side, for this one, this two operations cancel out, so just rewrite x minus 5, and we're done with that. Foil here, multiply, as I like to call it. Well, in this case I have an x squared, and I'm just going to rewrite the whole step here, square, but you can skip as many steps as you want. Okay, then x squared minus times negative 1 is negative 1 square times the square root of x, or negative x and negative square root of x. Same thing for this here, negative 1 times square root of x, that's a negative square root of x. And then last terms, negative 1 times negative 1, that gives me a positive 1, or positive 1 squared, if you want to write it that way. Rewrite everything else, and simplify. Go ahead and simplify. Well, here these two terms are the same. Okay, so I will combine those two together. Here I'm gonna go ahead and simplify that. That simplifies out into an x minus, since I have like terms here, I add them up. And both of them are negative, so that gives me 2 times the square root of x plus 1, okay, equals x minus 5. So just continue working that way, and you should get your answer. Okay, and here I can see that I can combine these two x's together by using the addition principle. Yeah, and this adds up to 0, this adds up to 0, so they go away basically. Rewrite 2x times, negative 2 times x squared times square root of x plus 1 equals -5. Use the addition principle here to combine like terms, and this adds up to 0, so I'm rewriting my -2 times square root of x. This adds up to -6. Continue working. Yeah, just solve for x, except for now you have a radical in there. That's okay. That's -2. Well, I use the multiplication principle. I'm dividing by the number I'm trying to move. Include the sign because that's going to make that positive, so that's good. And then do it to the other side, and this divides out to 1 times x, I mean square root of x, just square root of x, equals -6 divided by -2, that's a positive 3. Okay, now we have a radical on this side and a radical on this side, so we need to square both sides. So yeah, now we did use it twice. Okay, we used that rule twice. It doesn't make a difference how many times you need to use it, just go ahead and use it. Okay, this cancels out, well, these two operations. 3 squared, yeah, 3 squared is 3 times 3, same thing as x equals 9. Well, we are here, we said that x was equals 9, but we need to plug it into the original equation. See if that makes a true statement. Okay, so I'm just rewriting. Oh, what was the original equation? It was x, I mean square root of x, square root of 9 in this case, minus 1 equals, and I'm just looking at my equation down here. I will move the paper. I think I got it. Yes, that's exactly correct. Square root of 9. Okay, square root of 9 that's a perfect square. So that's a 3. 3 minus 1 equals the square root of. So in this case, you have an addition here. So go ahead and subtract first. Do not, by any means, do not do this. Don't go like this. Is the same thing as square root of 9 minus square root of 5. No, that would be wrong. Okay, that would be wrong. This doesn't work the same as multiplication and division. Okay, we're adding here, so we need to add them first. 9 minus 5 is 4. 4 is a perfect square, so the answer is 2 there. 3 minus 1 is 2. So that's a true statement. Therefore, x equals 9 is a solution of this equation. Okay, solution of that equation. All right, and that's the end of this section. Hopefully we have time to work some of these problems out in class. All right, I will see you on the next video. Okay.